Students, in this problem they give us the mass percent of all of the elements in an unknown compound, and they're asking you to provide the empirical formula. This is the common way evidence would present itself in a lab, where you would analyze an unknown substance and you would get the percent by weight or percent by mass of all of the elements that are in it. In order to do this, there are some steps to follow, and I'm going to jot those down as we go along. The first thing is it's really important to take the unknown sample and assume that you have a 100-gram sample. It's not that you couldn't do the problem without making this assumption, but it makes the mass percents a lot easier to deal with if you can assume a nice round number sample. Now, they don't tell you how much of the unknown you have, so it doesn't matter. They're just giving you a percentage. So if we assume a 100-gram sample, the 56.79% carbon becomes 56.79 grams of carbon if it's a 100-gram sample. And the 6.56% by mass of hydrogen becomes 6.56 grams of hydrogen. 28.37% by mass of oxygen becomes 28.37%. 23.37 grams of oxygen. And 8.28% by mass nitrogen becomes 8.28 grams of nitrogen. Okay, so assuming a 100-gram sample, you can just convert percentages into grams. Then take each of these elements' atomic weights and divide, so that you divide the number of grams you have by that atomic weight, and what you're doing is writing a conversion factor that lets you get from grams into moles. So that's actually the second step in this process, is to convert grams into moles. And in each of these cases, you would just take out your calculator. 56.79 divided by 12 gives you 4.73 moles of carbon. And for hydrogen, it works out to be 1 over 1, because hydrogen's atomic weight is 1, so you get 6.56 moles of hydrogen. You can still follow the units, even if the conversion factor doesn't mathematically do anything for you. 1 mole of oxygen is equivalent to 16 grams of oxygen. So 28.37 divided by 16 gives you 1.77 moles of oxygen. Again, the units of grams crosses out and you're left with moles. And then our last one, 1 mole of nitrogen has an atomic weight of 14 grams. So grams of nitrogen goes away. You're left with moles. 8.28 divided by 14 is equal to 0.591 moles of nitrogen. Okay, so now we've got the number of moles of each of the different elements, and that's really, really important. That's a key start to this problem. Then it's all downhill from here. Step 3 in this process is to write what we call a provisional formula. Oops. Provisional formula, because we're going to write it improperly. Yeah, we bad like that. The provisional formula will actually have decimals as subscripts. So if you take, they said that the unknown compound has carbon, hydrogen, oxygen, and nitrogen in it. And we now know how many moles of each of them we have. We have 4.73 moles of carbon. We have 6.56 moles of hydrogen, 1.77 moles of oxygen, and 0.591 moles of nitrogen. And if you were allowed in chemistry world to leave subscripts as decimals, then you would have the correct ratio of each of those different elements. But that's not proper. Not in our world of chemistry. And so step 4 is to neaten that all up. We'll take all of the subscripts in that provisional formula and divide it by the smallest subscripts, the single smallest one. After doing that division, look for whole number ratios. In the nice problems, the ones that aren't too complicated, it'll just work out to be a nice whole number for you. But sometimes you've got to keep an eye out for halves. So like 2.5, if that's a ratio, that can be stated as 5 halves. You should also keep an eye out for thirds or fourths. I've never seen anything besides either a whole number, a half, a third, or a fourth. They're not going to give you like an eighth and ask you to divide by that. So the smallest subscript within the provisional formula is, the only one that's below 1 is 0.591. So what we're going to do is take all of the subscripts within the provisional formula and divide by 0.591. And as we do that, we're going to look for whole number ratios. Oops. When you take 4.73 on your calculator and divide by 0.591, you get something very close to 8. When you take 6.56 divided by 0.591, you get something very close to 11. When you take 1.77 divided by 0.591, you get a number very close to 3. And by definition, if you take 0.591 divided by itself, you'll get a ratio of 1. Once you've done all of that, simply write your new neatened up formula. And usually you don't need to write the subscript 1. So if you wanted to, for WebAssign, you could just write C8H11O3N. And by the way, the order of the letters does not matter. You could write those in any order you wanted. As long as you have the correct subscript after each letter, then you're fine.